name, number, and date is not at the top. Use your red pen to put your name, number, and date at the top right now. Look above the words check my progress. If your name, number, and date is not there, put it there right now. Okay, the vocabulary part. Number 1, it says, in the equation 4 plus x equals 7, the variable x is a or an, Zari?
Unknown.
Unknown. Very good. So make sure if you get it wrong that you correct it with your red pen. Remember, you're only going to draw a thin red line through the incorrect answer and write the correct answer above. Number 2, in the table to the right, the letter M represents the blank. The letter N represents the blank. Cullen, what goes in the first blank? The letter M represents the input. Remember, the input is what you put in. It's usually the one on the left. Which means the letter N represents the output. The output is what comes out. So we imagine this imaginary magic box. The input goes in, the output comes out. Number 3, a blank is a sentence that contains an equal sign showing that two expressions are equal. Mason.
Equation.
An equation. The key word there is an equal sign because what is the base word of equation? What is the base word of equation? Carla, what is the base word of the word equation?
The base word of equation is equal sign.
The base word of equation is equal. Not equal sign, but equal. We can see EQUA, just like EQUA in equal. Number 4, addition is an example of a or an. Lena. Operation. Very good. Okay, so make sure you have all of those correct. And we will move on to numbers 5 and 6. Helper number, numbers 5 and 6, we have input-output tables. I love input-output tables. They make finding patterns so much easier. It says, write an equation that describes the pattern. Then use the equations to find the next 3 output numbers. Victoria, number 5. What do we automatically know right away? What can we go ahead and do without even having to really think about it?
We already know.
What can we look at and just know by looking? Colin, can you help her out?
The equation.
The whole equation?
Well, some of the equation.
Some of the equation. We already know some of the equation. Victoria, which parts of the equation do we already know?
The input and output.
Input and output what?
Input and output.
Lena?
Variables.
The input and output variables. What is the input variable?
A.
A. Where does it go?
It goes.
In the equation, where does it go?
It's the first part of the equation.
It's at the beginning of the equation. We also know the output variable. What's the output variable?
B.
B. Where does it go?
Behind the equal sign.
At the end of the equation.
But we put the equal sign beside it.
And we know that an equal sign comes right before the output variable. Do we know what goes in the middle yet?
No.
No, we don't. Or the sign, we don't know the rule. We don't know the operation and the number that goes with the operation yet. So now we have to go to our input-output table. Victoria, am I seeing what happens to 4 to get 5? No, because that's going from input to input to input. Do I do that, class?
No.
No. I see what happens to 4 to get 9, because I'm trying to see what happens to the input to get the output. I'm imagining that magic box. So, our input, is it greater than or less than our output?
Great.
Is our input greater than or less than our output?
Listen.
Less than. So that means there's only 2 possible operations we can be doing to get a larger output. What are those 2 operations?
Multiplication and.
Not and, because we're not going to do both.
Multiplication or adding.
Multiplication or addition. Let's try addition first. Well, we can actually rule one out, because is there anything you can multiply 4 by to get 9? No, 9 is not a multiple of 4. So that means we have to be doing which operation? Addition. Okay? What do we add to 4 to get 9? 5. Should we go ahead and write it in our equation? No, we need to check. Well, if I do 5 plus 5, do I get 10? If I do 6 plus 5, do I get 11?
Yes.
So what's my rule? Add 5. So my equation looks like
A plus 5 equals.
A plus 5 equals B. Am I done?
No.
No. What do I have to do now?
Now you have to find the next 3 output.
I have to fill in the input-output table, okay? Am I just going to change my rule all of a sudden just because I feel like it? No. 7 plus 5 is 12. 8 plus 5 is 13. 9 plus 5 is 14. There you go. Any questions? Everybody good? Okay. Number 6. Kingston, number 6. We already know some things. What do we know? Sit up straight, please. What do we already know? We don't even have to think about it. Think about the pattern. If you were listening when Victoria and Cullen answered this earlier, you know. The input and output variables. What's the input variable? Where does it go? Colin?
In the beginning.
At the beginning. What's the output variable, Kingston? D. Where does it go? At the end. You need to be louder. What do we always know goes right before the output variable? An equal sign. Do we know anything else yet? No, we have to go back here. Okay, our input is 6, our output is 12. Is the input less than or greater than our output? Please listen to the question I'm asking. Is the input greater or less than the output? Less. So that means there's only 2 operations we can be doing to get a bigger answer. What are those 2 operations? Multiplication or addition. Uh-oh, we always know we can add to a number to get a bigger number, right? Always. Like, that's just a thing. Multiplication is where you can't always do it. But uh-oh, that means we could do either one here, right, Kingston? Because we can multiply 6 by something to get 12. And we can definitely add something to 6 to get 12. So let's look at both of them. Kingston, what can we add to 6 to get 12? What can we multiply by 6 to get 12?
2.
Now let's see which one works. See, this is where some of you might say, oh, it's add 6. C plus 6 equals D. But, Kingston, if we add 6 to 8, do we get 16? No, what is 8 plus 6?
8 plus 6 is.
Use your fingers if you need to. 14. So we know it can't be plus 6. But what about 8 times 2? Does that equal 16? Should we stop or should we check one more time? we have another, we should check. Is 10 times 2, 20? So what's our rule? What's our equation?
C times 2 equals
C times 2 equals D. Now we just need to fill in the rest of our input-output table. 12 times 2 is
24.
24. 14 times 2 is 28. 16 times 2 is 32. Now that's where you might have to do this to the side. 6 times 2 is 12. Regroup the 1. 2 times 1 is 1. Plus 1 is 3. Please do these to the side if you need to. Okay? Especially if there's regrouping. Okay. Everybody good? Ready to move on? Make sure you have the correct answers with your red pen because you're going to be turning them in and I'm going to be checking to make sure. Smith, please sanitize, erase, sanitize. Hey, number 7. So this is find the value of each expression. Before we begin, I would like somebody to volunteer to tell me the order of operations. If you would like to volunteer, put your hand up and I will pick a stick. We wrote them like 3 times yesterday, so everybody should be like, oh, this is in my brain. Some of you hopefully wrote it here. Carla, what is step 1? We're going to put
Step 1 is to check for parentheses.
parentheses. Keep your hand up if you want to volunteer. What is step 2? I'm putting you back in the cup after though. Zadie.
We multiply and divide from left to right.
Good. I'm just going to abbreviate. Multiply and divide from left to right. Number 3. But if I pick you a second time, I am going to put you back. Smith.
Add and subtract from left to right.
Add and subtract from left to right. So we knew we had to solve this on a separate sheet of paper. So now go to your separate sheet of paper where you should have 7 and 7 plus 5 divided by 3 equals, hold on 1 second, okay. So Ethan, we're just going over the back, you can catch up. Okay. That's me.
We need to do the rest after.
Have you finished? Just follow along with us, okay? Okay, I just picked a stick and I put it down and I forgot, I think it was Zadie. What do we do first?
You do what's in parentheses.
I do what's in parentheses. So even though it's addition, which is supposed to be step 3, what changes it to doing it first?
If it's in parentheses.
The parentheses. Very good. So, I draw my caret. 7 plus 5, Zadie. Use your fingers if you need to. Don't hide them.
12.
Be loud and proud with your fingers.
12.
12. Say, I'm doing it right. I don't care who sees me use my fingers. I'm making sure to do it right. And then we bring down. We only have we have no variable, and we only have one operation left, so we don't have to do a caret. We can just put it up here. What do we have left? Do we have any more parentheses?
No.
So we're ready to move on to step 2. Do we have multiplication or division?
Yes.
Yes. 12 divided by 3?
4.
4. And it should have moved over here. If it did not move to your paper, use your red pen to move it to your paper. Very good. Number 8. I can see, I think before you girls got in here, I was telling everybody this lesson is going, this chapter is going so much faster. Because I think you finally realized. Listen, follow along, find the patterns. It makes math easier. Okay. Number 8. We have 11 minus 2 times 5 equals something. Michaela, what's step 1?
Parentheses.
Do we have any parentheses?
No.
Does that mean this problem is broken and we can't solve it?
No.
No. We just move on to step 2. Do we have multiplication or division to do?
Yes.
Yes. What do we have?
2 times 5.
2 times 5. So we draw our caret. 2 times 5 equals 10. We bring down. So we have 11 minus 10. We have no variable here. We only have one operation left, so we don't have to do another caret. Do I have any more multiplication or division to do?
No.
So I move on to step 3. Do I have adding or subtracting to do?
Yes.
Yes. What do I have?
11 minus 10.
11 minus 10, which equals
1.
1. If your answer did not move over, move it over with your red pen. Okay, everybody with me and ready for number 9? We have a good old input-output table with a word problem. Does that really change what we do at all? No. Okay, number 9. The amount of dollars, C, a bus company charges to take S students on a field trip are shown at the right. Now I know that sentence confused some of you. Who knows what this sentence was just trying to do? What was it giving you? Aaron? It was giving you the variables. That was all it was doing. Aaron, since you told me that, which variable is the C, the input or the output? The output, because it says the amount in dollars, C, well, cost is dollars, which means S is which variable? Input or output? Input. Because it says charges to take S students on a field trip. That's it. That's all it was doing, was just giving you the variables. The rest says, write an equation to describe the pattern. Then complete the table to show how much it would cost for 40 and 50 students to go on a trip. Okay, Carla, you're going to tell us the equation.
The equation
We already know what parts of our equation. Think of what we did when we did numbers 5 and 6.
is
Well, we know which parts of our equation. The
input and the output.
input and output what?
Variation.
Not variables.
Variables.
What's the input variable?
The input variable is S.
Where does it go?
It will go in front.
At the beginning. And then what's the output variable?
The output variable is C.
Where does it go?
It will go at the end of the variable plus
At not the end of the variable, at the end of the equation.
the end of the equation, and you will put the equal sign in front of that C.
Very good. Now I'm giving you this because when you get to your test, what is a good I'm giving you a model of how to solve this quickly and get the parts you know out of the way. Do we know the rule that goes in the middle? No, so we have to go to our table. So remember, our input is 10, our output is 60. Is our input greater than or less than our output, Carla?
Our input is less.
It's less. So that means there's only 2 operations we can do. What are they?
Add or multiply.
Add or multiply. Uh-oh, we can do either one, right? What can we add to 10 to get 60?
We can add
Here's a way to solve that. If you know you have to add, take the output, subtract the input. 60 minus 10 is
50.
50. Because we know addition and subtraction fact families work the same as multiplication and division, right? 60 minus 10 equals 50. 50 plus 10 equals 60. Right? That's just how it works. They're backwards. They're opposite of each other. So we could be adding 50, or we could be multiplying what?
We can be multiplying 6.
We could be multiplying 6. That's why it's important to keep checking. Because if I just said, oh, I multiply 6. Is that what we do every time, Carla?
No.
No, because is 20 times 6 70?
No.
Use basic facts and patterns. No, 20 times 6 is 120. So that means we definitely aren't multiplying by 6. Let's check if adding 50 works. Is 20 plus 50 70, Carla?
Yes.
Yeah. 2 plus 5 is 7. 0 plus 0 is 0. Is 30 plus 50, 80.
Yes.
Yes, 0 plus 0 is 0, 3 plus 5 is 8. So that means, what's our rule?
Our rule is to add 50.
Add 50, which means we can fill in the rest of our table. 40 plus 50 is
40 plus 50 equals
90.
90.
There you go. And 50 plus 50 is
100.
100. Hey, does everybody see? Does everybody see why I did these? And why I figured out everything we could do? Zari, yes, quickly, because we need to do the last couple.
I use the cost I use the variable from the table.
This isn't a variable, so you needed to use C. It's telling you the amount in $C a bus company charges. A dollar sign is not a variable. Remember, a variable is a letter. A variable is a letter. Is a dollar sign a letter, class? No. Victoria, quickly.
So what do we have to show on our solution?
That was if you needed to do this, which is always helpful. Okay. Number 10 says, a local sports team sells 6 tickets for $3. That means you buy 6 tickets, you get $3. I'm sorry. You buy 6 tickets, you give them $3. 8 tickets for $4. You want 8 tickets, you give them $4. And 10 tickets for $5. You want 10 tickets, you give them $5. Write a rule and equation to find the cost of 20 tickets. If you see, write a rule and equation in a word problem. That should trigger something in your head. Oh, I need to create a, Carla?
A input-output table.
I need to create an input-output table. So, got my input-output table. Here's my input. Aaron, what variable would you like to use for the input? The amount of tickets. C. And what would you like to use for the output? The total cost. S. And we know if we sell 6 tickets, it costs $3. If they sell 8 tickets, it costs $4. If they sell 10 tickets, it costs $5. Then it says, write a rule and equation to find the cost of 20 tickets. Do I have to keep going 6, 8, 10, 12, 14, 16, 18, whatever, until I get to 20? Aaron, what can I just do right here? Do I have to keep making columns and columns until I get all the way down to 20 following this pattern? What can I do right here? Put in this input. I can just put the 20 tickets and then solve. That's all I'm doing. Hey, Aaron, I need to write an equation. What do I already know? What can I just look at this table and see? The variables, the input and output variables. Now, your input-output variables probably look different, unless it is a massive coincidence. So as long as your input variable is first and your output variable is last, that's fine. So what comes first in our equation? C, the input variable. And then we know, where does the output variable go? At the end. And what goes right before the output variable? The equal sign. Do we know what goes in the middle yet? No. Let's go to our input-output table. Our input is 6. Out comes $3. Is our input greater than or less than our output, Aaron? Greater. So that means there's 2 operations we could be doing, right? What are they? We could be subtracting or we can be dividing. What can we subtract from 6 to get 3? 3. What can we divide 6 by to get 3? So we need to figure out which one works, right? 8 minus 3 is 4. True or false? 10 minus 3 is 5. True or false? So are we subtracting 3? We're probably doing what? Let's see if it works. 8 divided by 2, is it $4? 10 divided by 2, is it $5? So what's our equation? C divided by 2 equals x. So, in order to be correct, you need your input variable divided by 2 equals output variable. But are we done yet? No, because what's the last part of the problem? Look at the word problem. What's the last part that we have not solved yet? The answer to what? What equation? Smith, what have we not figured out yet?
20 divided by 2.
What have we not figured out yet?
The cost of 20 tickets.
The cost of 20 tickets. Are we going to change the rule here just because all of a sudden we went off pattern?
No.
No. So if I buy 20 tickets, how much do I have to pay?
$10.
$10. Which means the cost of 20 tickets is what, Smith?
$10.
$10. So there you go. That's how you would solve. Yes, Zadie.
Miss Douglas had me go from 10 to 12 to 14 to 16.
That's fine.
to 18.
That's fine, but that's good practice. But like when you get to your test and stuff, you don't have to do that. That is fine, because remember, are we too worried about this pattern? Going from input to input to input to input? Not really. But it's good practice. But you don't have to do that as long as you have what they do give you and what you need to find. Then that's fine. Okay, number 11. We have another word problem. Each peanut butter snack costs $2. This sounds a lot like our examples yesterday with the fruit servings, right? So do you think we're finding patterns, or do you think we're probably solving an equation? Victoria. Yeah, we're probably doing something different. This sounds a lot like it. So we're going to pause and we're going to draw a picture and we're going to visualize. Each peanut butter snack costs $2. Here's my peanut butter snack. I know it's $2. Now this is small, but all I'm doing is a rectangle with PB for peanut butter and $2. Each chocolate snack costs $3. Okay? I'm going to draw my chocolate snack, and I know it's $3. How much does it cost to buy 6 peanut butter snacks and 8 chocolate snacks? Kingston, that question, how many peanut butter snacks are we buying? 6. How many chocolate snacks are we buying? So now, are we finding the total cost of peanut butter snacks? Is our final answer the cost of peanut butter snacks? No. Is our final answer the cost of chocolate snacks? No. Our final answer is the cost of what? All of them, all together. So, can we just do all that multiplication at once and all that addition and all of that at once? No, we have to write an equation. What should our equation look like? First, we have to find the cost of the peanut butter snacks, right?
Yes.
What tells us, what equation will tell us the cost of the peanut butter snacks? You don't have to use a variable until the answer. You do for the answer, yes, but not, do we need, is there anything we don't know in the equation itself? Or is it the answer that we don't know? So, what equation do we use to find the cost of the peanut butter snacks?
8 times
What?
8 times 3.
Why would we do 8 times 3? Peanut butter snacks are $2 and we bought 6.
Oh, it's 6 times 2.
6 times 2. That'll tell us the cost of the peanut butter snacks, but that's not our final answer. Because we also have to find the cost of the chocolate snacks. How do we find the cost of the chocolate snacks, Kingston?
8 times $3.
8 times $3. And then are we finding these two separately and saying, oh, peanut butter is this much, chocolate is this much? There we go, there's our answer. No, what do we have to do with these costs?
We have to add
We have to add them. And then we're going to get what? What did you use as your answer variable? D. Do we need any parentheses or anything here? No. Now we're going to go to our separate sheet of paper and use the order of operations. If you put parentheses around each multiplication, you are not wrong. That's fine. If that's helpful to you, do that. Just make sure that that it's just around each separate multiplication problem. Okay, so now we're going to go to our separate sheet of paper, and we are going to rewrite our equation exactly as it appears with dollar signs and everything. And we're going to solve. Kingston, thank you for doing the first part. This is a long problem, so I'm going to have somebody help with the second part. Smith, you've helped with a lot of them. Colin, what do we need to do first? We're following the order of operations. What's step 1?
parentheses.
Parentheses. We do have parentheses here. We have 2 sets. Do I have to do one and then bring the rest down and then do the other?
No.
I can just do them both at the same time, right?
Yes.
So, I know I'm solving 6 times $2 and 8 times $3. 6 times $2 is what?
$12.
$12. 8 times $3 is
$24.
$24. Bring down my plus sign. And my variable. I don't have a line, I have a variable, so I need another caret, right? Do I have any more parentheses?
No.
So I move on to step 2. Do I have multiplying or dividing to do?
No.
So I move on to step 3. Do I have adding or subtracting to do?
Yes.
Yes. $12 plus $24 is $36.
$36.
Do I have anything else to do? No. So that means D equals $36, which means how much does it cost to buy 6 peanut butter snacks and 8 chocolate snacks? $36. There you go. It's just like example 1 with the movie tickets. Same exact thing. Okay, last one, number 12. What is the value of m in the equation to the right if n equals 6? Smith, I keep picking you, and I feel like you've done like 3 problems today. Zadie, has anybody not had a chance to do a problem? Okay. Let's see. Whoever I pick first out of Lena, because you've done, I think you've done, so whoever I pick first out of Lena and Ethan, that's who gets to do it, okay? And I just picked Lena. So, we're trying to find the value of m in 9 times n equals m. And the equation tells us that n equals 6. So that means, what is our equation? 9 times 6. Remember, a variable replaces an unknown. So if they tell you what the variable means, is it unknown anymore? No, we just take out the variable and put what we know. So we're solving 9 times 6, which equals 54. So so the answer is
54.
what letter?
C.
C, 54. There you go. Any questions about this lesson? Or about this Check My Progress? When you look for the patterns, it makes it easy. Okay, make sure your name, number, and date is on both sheets of paper. Back row. So there's 3 rows now. There's back, middle, front. Back row, go ahead and turn in your Check My Progress. and then get out your things for Phantom Toll Booth. Those of you at home,